Okay, in this video we're going to go over question 6 from homework 3 and just briefly look at how we can go through these files and parse them effectively. Okay, so first thing we're going to do is let's go ahead and in here the code block to determine whether the function works or not. We're going to read in all XRD signals. Now I've read it in as a pandas data frame, and then I've extracted the NumPy array values. Let's go ahead and read that in, and let's go to our variable explorer and just look at it. So here we need to grab all XRD signals. We're going to open it up. We're going to see the 2 theta column, and then we're going to see our signals. And then we have another 2 theta column. And people have noticed this that have been working on the homework. This is a mistake on my part, and so if we look, the answers I supplied actually won't be correct because I didn't see this 2 theta column was actually in there. So what we're going to do is we're going to remove these answers, and we're going to get the actual signal. And I'm doing this sort of as a first pass. I haven't looked too much at it. So what should happen is you should see how I approach one of these problems. It's been a long time since I wrote the solution, and there's a lot of different solutions you could do. Now I'm going to start with this get XRD peaks function. This is what I'm going to be building because I see down here that it's what gets called to generate my answer. So I need to return a list of lists, and I think it says that in the problem statement. If not, you should be able to tell because we're going to be comparing Q6 my answer versus Q6 answer over right here. So we need to make sure all signals match because they're going to be compared against each other. So you can know the structure of your answer just by looking in this little block here. Okay, so how do we do this? Well, first thing I'm going to do is I'm going to get all signals equal to all XRD signals, and I'm going to do a .copy. Now what this does is it creates a copy of the object rather than assigning this array to the new variable. So if I don't copy it, sometimes what can happen, depending on your usage, is all signals points to the same thing all XRD signals points to, which is this array. But now what I'm doing is all signals points to a copy of that array. So these won't be variables pointing at the same object. Okay, so now we have all signals. The next thing I want to do is I'm going to go ahead and do all signals. And I noticed that there was that weird pattern here at the 0, here at the 6, the 12. So it looks like every multiple of 6 has an issue, 18. So what I'm going to do is I'm going to try and think of a way to loop through this. So probably simplest is we can see if NumPy has a remove function. So I'm going to go here and I'll say NumPy remove columns using index. And this is just a way maybe I can simply tell it to remove these. And here we have delete second row, delete third row. Column-wise with axis equals 1. So let's go ahead to the documentation, numpy.delete. Return a new array with subarrays along the axis deleted for one-dimensional array. Okay, so we're going to look. It takes in an input. You tell it which arrays to remove and which axis to delete them along. So let's go ahead and try this out. We're just going to see what happens here. So I'm going to make this copy. So all signals is now up here. And go all signals. And it's just a copy. Now next I'm going to do all signals. And it was .delete, I believe. Let's see if we give it a 0 and a 1. And let's see, it wasn't all signals, it was numpy.delete. So we're not going to do all signals. It's not a method associated with this array. So what we can do is we can say all signals equals mp.delete. And then over here, the parameters, the first thing you give it is your array that you want things deleted from. So we'll give it all signals. And then we give it the subarrays to remove. So it was like 0, 6, etc. We're just going to try 0 and 6, and we say axis equals 1, so it removes across the columns. So let's go ahead and look at all signals. If I delete this, okay, all signals, oh perfect, they even have different variable names. removed 2 columns, and we see that 2 theta value is gone. So now what I'm going to try and do is I'm going to say remove columns, and I'm going to make a variable called remove columns. Let's go ahead and get these variable names right. And for remove columns, what I'm going to do is I'm going to make a NumPy array, np dot let's see, a range. I'm going to go from 0 to, how big was our size? 42. And I'm going to ask for multiples of 6. So let's go ahead and see what this does. So when I run that, we can come here. It makes 0, 6, 12, 8, 24, 30, and 36, which are where these 2 theta values live. Now we don't want the 0 because we want at least one of these 2 theta values in our data. So what I can do is I can go from 1. Let's see what that does. So that steps up. Okay, so we want to start at 6. Perfect. So I'm going to run this, and we're going to see, okay, 6, 12, perfect. So now I'll remove those columns along axis 1. Let's go ahead and run this. So I'm going to, all XRD signals is the original data. All signals is now a copy of that data. We have remove columns, which is the columns we want to get rid of. We're going to redefine all signals to be the old version of all signals, where we've removed the columns along, well, where we've removed these indices along the columns is probably how we should say it. Excellent. So let's run this. And we'll see how all signals is updated. All signals is now 7 by 36. The first column is our 2 theta values, and looks like we're in the clear for the rest of it. Expecting that. Okay. So now we've gotten rid of the 2 theta values. What's the next step? Well, we can calculate the global maximum now. Now I know the 2 theta values, just by inspection, are smaller than the signal values. So I'm just going to go ahead and say global max equals all signals. And we'll say everything. In fact, we can even just not even include the 2 theta. We'll just start from row or column at the index 1, or so the second column, all the way to the end. Let's go ahead and see what, if this does what we want it to. Now a tip, you can copy this in here and do .shape to see what it looks like. So in this case, it looks like we took off the first row. So we'll say all rows in this column. Okay, so now for global max, let's go ahead and look at all signals. Okay, and let's grab the shape of that, just for my sanity. I might have just done this, but want to double check. Perfect, so we got rid of that 2 theta. Now here, I'm going to wrap it in an np.max. And this gives me 1541 for my global max. And I think I can even do like a max, and I'll get the same answer. So a max, this is a tuple of ints. The maximum is selected over multiple axes. Perfect. So this is the absolute maximum of all of them. All right. So now another step I'm going to do here, now that I have my global max, when it comes to the signals, our problem statement asks to ignore everything under 2 theta equals 5 and above 2 theta equals 30. So if we look at all signals, there is nothing above 2 theta equals 30, so we're good on that case, but there are some below 5. So what I'm going to do, since we don't want to find max values if they exist there, I have what I think is a simple solution. I'm going to say all signals where all signals in the first column, in the first column is less than 5 equals 0. So now if we have all signals open, and if I run this, and we open all signals again, so I've zeroed out everything where 2 theta was less than 5. So now that 2 theta is 5, we get our max values. And so if I search over this, there's no way I make a mistake. Okay. So to break down what I just did, let's go ahead and do this slightly different. I'll say values. We'll say index. We'll say, no, let's go with rows. where 2 theta less than 5. And those rows are this logic right here. All signals for the first column, or all signals across all rows for the first column where it's less than 5, return me Boolean values. Store those Boolean values into this absurdly long variable name. And then all signals is indexed where all of these values are true and assigned a value of 0 where these are all true. Let's go ahead and run this from the top. Now we have all signals where it's zeroed out until 2 theta is equal to or greater than 5. We have our global maximum already calculated. Let's go ahead and, just in case, we can put our global maximum down here so we don't include those values where 2 theta is less than 5. I think it'd be fine either way. And as the next step, what we can say is, well, we have peak info we're keeping track of. So I'm just going to make an empty dictionary, and I'm going to loop over, or an empty list, excuse me, and I'm going to loop over this. So for signal, is that how you spell signal? There we go. For signal in all signals, so I'm going to loop over this. Now I'm going to go ahead and print signal. We're going to see what happens. Okay, so what happened there? Well, signal, let's grab the shape of that. Signal.shape. Print statement didn't help much. So this is shape 36. So when we do this, when we're looping through all signals, notice the columns are 36 long, and there's 700 rows. So what I can do here is I'm going to enumerate this. So enumerate just lets us count what loop we're on. So I is going to start at 0, then 1, then 2, then 3, then 4, then 5. Let's go ahead and print I and see what happens. So you'll see we looped through this 700 times, which means we're looping not through all signals columns, but through all signals' rows. So if we transpose this, the columns become the rows. So .t will transpose, and if we didn't know that, we could say numpy transpose matrix. And we'd get the same results. Maybe we'd use the matrix.transpose command. Or maybe if we click on a Stack Overflow link, someone would tell us a.t. So pros and cons versus documentation and Stack Overflow. But now we're going to transpose it, and you'll see we're going to iterate through columns. So we started at column 0 and we went to column 35. So what are we doing this for? Well, for each signals run across the columns, like the 2 theta value ran down the column. Each XRD signal runs down the column. So for each signal, what I'm going to do here is I'm going to grab the index associated with the max value. So mp.argmax is going to grab the index at the max value, and I'm going to grab the index of the max for that signal. And now that I know, let's run this actually. Now that I know the max signal lives on index 167, I can easily say max 2 theta has to be on that same index. So that would be my signal at the max index, but we only want the first column. So what I'm doing here is I'm grabbing all rows across the first column. Oh, excuse me, too many indices. So signal dot shape. Oh, we don't want signal. We want to go to all signals because all signals has our 2 theta value. So all signals in that first column, that's kind of ugly. Let's go ahead and, here's my pro tip. You do test equals and you make a test variable, and you can inspect this nice and pretty. So this is in fact our 2 theta values. And so at the max index, that's where our max signal is. So at 2 theta equals 8.75, we have a max value. And then similarly, for our signal, that max index is the max value. So we have a max value of 898 at 2 theta equals 8.72. So this is our max 2 theta, this is our max peak. And now what I can do is I can do peak info.append max 2 theta and max peak. So let's run this loop and see what we get. Oh, so we tried to append 2 separate items. Let's go ahead and wrap those in a list, and we'll append the list. So we're appending this list here, where this is my 2 theta, and this is my max peak. Now, you'll see at this point, we've made an error because these peaks are absolute values and they haven't been normalized. So our max peak, we're quickly just going to divide by the global max. And there, we should now have a decent answer, where we have two theta values and max peak values. Now you'll notice this first one looks a little funny. Why is this a 30 where everything else is around 8? Well, that's because we forgot all signals. Let's actually go to the all signals. Its first column is the 2 theta values. So what we can do is we can say if I, which is counting how many times we've been through the loop, if it's 0, that means we're on that first column, the 2 theta column. We will just continue. So now we have a full solution where peak info, where is it at, has lists with 2 theta values and maximums that have been normalized by the global max, which apparently is on column 24. 2 theta equals 8.6. All right, and you'll notice these values mostly match besides these extra 30s what the 2 theta values were. Okay, so that should be your solution for homework 6. Now there's a number of ways to do this. I'm definitely not going to say this solution's optimal or even good, but it gets the job done, and I think that's enough for most engineering applications. Now, one last thing so we can make sure this code would run properly is let's go ahead and return peak info. So we built this entire function, and it was thinking, and it was doing, and it was making results, and now we want to return those results. So we'll do that part here. All right, so we're going to do this. And for the sake of checking that we're right, let's go ahead and remove that. Ooh, nasty. Remove this, 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 and this. Let's run it. Perfect. So there you go. That's question 6. Good luck. And if you need to update your homework, send me a special email and let me know.